Hello, everybody. So we just want to check whether everybody has got a chair to sit down and is comfortable. Are there any chairs missing? Does anybody else want a chair? No, but do you have you got enough chairs at the moment? Have you got? Is everybody sat down? Nobody's hovering. That's lovely. Thank you very much.
Michelle, would it be possible just to have the this one light on? Yeah, thank you. Yeah. Oh yeah, just everybody happy with the lights on? Just this one would be great. Yeah. Oh, okay, right. Are we all? I think we'll start.
Yes.
Yeah.
Turn yourself on.
Yes, I am on. Good evening, everyone. I think we'll make a start if that's all right. Thank you very much. No talking. Anyway, a very warm welcome to what I think is our fourth session. And can I, newcomers, because I see a number of new faces. Denise and Bruce, I think. Just here. I'm sorry. And has everybody got a chair? So to sit on, we're all comfy. I think it's fair to say also that the range of topics we've had so far has been quite eclectic. And this evening we're going to be very grounded in geology and Rhosneigr rocks. And sorry, that was a sort of unintended joke. Well, yeah, the jokes will get better when Chris speaks. And we're very lucky to have in our midst an acknowledged expert on geology and Rhosneigr rocks. Can I just mention a few housekeeping points? Please do keep your glass replenished, where Nathan will be happy to look after you throughout the evening. He's the chap behind the bar. And after the discussion, there is hot food from Gather. So I think the thing is you pay Nathan for that, and you can order your food direct. Can you just possibly resist the temptation to order food in the middle of the discussion, because that can be a little off-putting, but I'm sure you can resist that. And we've also arranged for you the Rhosneigr Supper Club. So if you're tempted and you get a bit fed up listening to Chris and myself banging on, then you can treat yourself to a gastronomic blowout and join the supper club. Actually, Chris and I would be I think we're quite a bit upset if you did do that, but hopefully anyway, the food from Gather will more than make up. The usual rules of engagement apply. They're on the screen, or they were on the screen behind me, and I forget what they are now. Sorry, we're going to see that now.
Yes, you are.
No, oh, yes, thank you. Now, Chris will take this in good part, but preparing for what our speaker was going to say this evening has been a bit of a nightmare. And the reason for that is that Chris himself had not really decided what he was going to say in advance. So I did look at his book, which is this excellent publication, which is also going to be available for purchase after the evening. And Chris will be signing copies of this for you, if that's all right, and has agreed to donate a proportion of that to the RNLI, a local charity. What he wasn't going to do was go into long discourses on the theory of time. And the great British philosopher here was somebody called John McTaggart, who, by all accounts, was I think Nigel was a fellow of Trinity, Cambridge at 25, but a weirdo. And but in the early 20th century, he came up with his theory of the proof of the unreality of time, you know, A series and B series time, that sort of thing. You'll be relieved to know we're not going to go there this evening, but if you want to hear more about John McTaggart, then have a word with me afterwards. I think as you listen to the story of the amazing story of Rhosneigr rocks unfolding over hundreds of millions of years, my hunch is that you will begin to think that there is no absolute distinction between past, present, and future. And perhaps further, that our view of ourselves, our self-images as observers moving through time, is seriously mistaken. And ultimately, perhaps the ultimate Zen thing, that space and time, are they real existences? So that will be food for thought as Chris takes us through Rhosneigr rocks. Now, to our speaker, Chris has had a very different lifestyle from most of us, I guess. For 5 years, he headed up the Hong Kong Geological Survey before setting up his own consultancy company. And he's clearly in his elements, slashing his way through Central American jungles and in his element, sort of putting up with all the bugs and creepy crawlies and foregoing the usual creature comforts. He's also an honorary, or was an honorary professor at 3 universities in the Republic of China. He's also taken non-geologists on field trips through Nepal, Tibet, and southern China. And I think here's the clue. It is his passion to share his knowledge with non-experts like ourselves. And it is our good fortune this evening that he can speak to us. So I suggest that Rhosneigr rocks will never see the same again when you look at them next. Please welcome as your speaker this evening, Professor Chris Fletcher.
Up in an impossible situation in talking. Get it right. Today or this evening, I'm hoping when you go away, you'll never walk along the Rhosneigr beach the same. You'll be looking and saying, wow, I didn't notice that. But I'm going to take you through. I've got to give you a little bit of geological background. This is not going to be a geology first year course at all. But there are a few things which you may not know, and I'm going to go over them. If you know it, sorry, but it's going to be very quick. I'm going to focus on the geology of Rhosneigr, but extend it a little bit to the rest of Anglesey. You are very fortunate here to be in Anglesey. It is an amazing geological terrain. It is absolutely phenomenal. And it's unique in the British Isles. And it's been studied a lot. I've done a little bit, but not very much. So hopefully we'll get started. I don't ask for questions in the middle. It'll put me off. So we will try. That picture was taken this morning. As most of my lecture notes were done sort of last night and just getting on. I don't have lecture notes. I just go through it. So here, that is this morning. When you finish this, you'll look at that picture and say, gosh, I didn't realize that was the case. You are looking at rocks in the foreground, which you know, these black rocks in the front foreground, which are Ordovician in age, which is, you know, running at about, I suppose, about 500 million years. Across to the rocks in the background, this is, I suppose, at the end of Starvation Island. And in the background is Holyhead Mountain, which I'll come back to many times. At the end, you will all be asked questions to make sure you've listened. So no excuses. So there's no discussion. I'll ask questions and you'll find out whether you've actually listened. Can you have next? Shall I just press it? Yep. I'm not going to tell you what they are. I'm just going to show you. These were taken on Rhosneigr Beach, basically. And they tell the history of what's happened here. At the end, you should understand a little about what they are. I'm just going to do 4 slides, which give an inkling of what you're going to expect. You've probably walked over these. You'll never notice them. You said, well, fair enough. What do they mean? That question didn't even cross your mind at all. There's another. That's at the other end of Broad Beach. And we'll look back later. And the final one is that. Interestingly, that was taken about 15 or 20 years ago. It is now different. It's already changed. The world is changing, but it's changing at a rate which has happened through hundreds of millions of years. And that is a very important point to make. Okay, so that is what you are going to be able to understand later on. The time element David wanted me to look at, and I had a lot of thought process, and because as a geologist, you're always thinking about how long did this happen? Quite a long way, but the exact measurement is only in the last 100 years. And finally, missing time, which would be very good for David. Very philosophical thought I did. So that is the geological time scale, worked out over many, many years. Some of the names you'll be familiar with, like the Jurassic. If you haven't seen Jurassic Park, you should have done. So here are some of the what we would call the geological time scale. Now, it's interesting that the Cambrian, Ordovician, and Silurian all were named after the Cambrian mountains of Wales. The Silurian and Ordovician, both of those are tribes of Wales. Now, it's fascinating to note that if you go to China and you talk about the Cambrian and Ordovician, they just use them quite clearly. They don't realize they all came from Wales. And if you subdivide, let's say, some of the Ordovician and Cambrian, you have the Llandilo, the Llandovery, and this is in the middle of China. You'll be talking the same thing. And the reason for that is that most of the geology was started here in Wales with Murchison in the sort of early 1800s. And they developed all this. And they generally, as you go up the column, you can actually pick them up. The Devonian is obviously named after Devon. The Carboniferous is obviously coal. And then you go through the Permian and Triassic are from the Permian across in Europe, the Jura Mountains and Cretaceous, etc. The numbers which you see along here are the millions of years. Those were not known until very recently. Probably starting about 100 years ago and coming forward. And we'll come back onto that in a minute. But that, if I talk about the Cambrian, Ordovician, and Silurian, at least you'll know what I'm talking about. The thing about Anglesey and Rhosneigr in particular, we start in the Precambrian, the upper part of the Precambrian. And we go through the Cambrian, we go into the Ordovician, and maybe clip into the Silurian, and then there's a gap. We have none of the we have none of the Devonian, or very little of the Devonian, and then the Carboniferous. We get the limestone. You must have seen the limestone. That is, and then from them there's a big gap. All those are not here seen in an Anglesey at all. Let's go forward. Measurement of geological time. Very interesting. You go back a long way. When people realized, when they saw fossils and everything else like that, they said, well, how could this happen? You remember this, it was a very religious time. And to Leonardo da Vinci, he was an exceptional scientist. And he saw these fossils high up in the Italian mountains and said, how did those get there? That must have taken a long time. And that's as far as he went, because the religious feeling at the moment, anything like that, was due to the major biblical flood. Everything was about the biblical flood. And that's as far as he went. Now, this man, Bishop Usher, came from Armagh. He decided, he worked out how long it took when the creation of the earth came. And he did it by genealogy, begat, so many begats. And finally came that it was actually on October the 23rd, 4004 BC. In the evening, I might add. And that was his whole thesis. But that was after someone like Leonardo had pointed out this was obviously going to be a lot longer. It wasn't until the late 1700s that James Hutton, an incredibly erudite geologist, who developed the theory of uniformitarianism, which sounds very religious, as though it's a sect. Well, it is in some respect, because what he said is that everything is going on at the same speed, and things like the landscapes, mountains, required an immense length of time. He didn't know what the length of time was, but it was obviously a lot longer and certainly wasn't 4,000 years ago. And then, critically, in 1905, following Madame Curie's work on isotopes, Boltwood decided that the isotopic composition of a rock, and once it's actually formed, it then starts degrading through the isotopes, and from the half-lives you can work out what the age of the rock was, and that was critical. And that is how all those numbers I showed you on the geological column actually came to be. This was one of Hutton's famous outcrops to the near Edinburgh at Sicker Point. And if you notice, and geology is all about noticing things and saying, gosh, how did that actually happen? If you notice, the rocks under here are vertical. Now, vertical rocks, remember, most sediments were laid down horizontal. Pretty well all of them were. And so to be vertical, that had to have been some form of mountain building or something else like that. But look here, we have pretty well horizontal rocks above them. And there's a line between them. And this is what they call an unconformity. And it's this missing time, which you actually got to think. There's somewhere in the region of 500 million years along that line, which is not there. It's missing. And we'll see that as we go through the rest of them. Dunraven Point. And here, I've put the ages. We've got, again, rocks on an angle, which are Carboniferous limestone, 350 million years old, and overlain limestones at 160. The line between them is what has happened there. And that is, funnily enough, it's the missing times which actually you can correlate a lot better than actually the strata themselves. I'm going to give you a chance after, when you're having your beer or whatever, I'm going to chance to actually look at an unconformity. I've brought one along, which is a rare thing to do, is to bring an unconformity along. And that is this. You can't have a geological talk without a rock. Come on. That is the unconformity which I just showed you, which I cut a slice through. Here you've got the Carboniferous limestone, you've got the Jurassic, which you know, Jurassic, dinosaurs, all that type of thing above it. Now look at these holes. These are burrowing mollusks, which went actually into the rock along that line and burrowed in. There again, you have somewhere in the region of 200 million years along that line, which is missing. Very important point. Have a look at it. It's a fascinating, it's nearly a unique specimen. That. On angle, we see an unconformity, but it's not, I wouldn't say spectacular. Both, we have Precambrian, which is 900 million years old, underneath at an angle, and on top, we've got glacial gravels. Yet again, here, you can see there's nearly 900 million years missing along that line. What does missing mean? It means that there is no deposit. It means that there has been uplift. And more importantly, it means there's been a lot of erosion, a vast amount of erosion, an erosion which is going on today. It's the same speed of that erosion. So that is critical. So that's the only unconformity I know of in Anglesey. We're now going to have a, where's it gone? Where's it gone? We've missed a point. I've got to go back. How do I get back one? That's it. Got it, got it, got it. This is the most simplified geology map of Anglesey. Doesn't have anything to do with time. It's just the type of rock it is. As you can see, all running along in that direction. Basically, the oldest rocks, which are the green in color. And these consist of a whole load of rocks in there, from granite to lava flows to quartzites and a whole lot in that area. Very, very complex and has been studied in great detail. There was a period of mountain uplift, mountain building, erosion along here, and then you had mudstones. And that's the important one for Rhosneigr. because the ones which you see in Rhosneigr is that band of mudstone. And on top of that, again, another something uplift, a lot of erosion. And then you have the limestones, which are here, which you see at Llwydwy Bay, at Red Dwarf Bay, Puffin Island, which come along here along the straits, the Menai Straits. So that, when I start talking about some of the remember the granite, because that's quite important, the granite. And you can see it here in Rhosneigr, but not, it's not that easy to see. I'm afraid I'm going to have to give you a little bit here, because one of the things which you can see, if you go and look at the Carboniferous limestone, the limestones, you'll see fossils in them. Fossils which are like corals and things like that, which were in the tropics. So how was Wales in the tropics? So very briefly, I'm going to give you an idea of all the plates, the continental plates which you have. This is the modern day plates, a whole series, and the ones which are, you can see the South American plate here. More importantly, that little crack between Africa and South America goes along the South Atlantic. So there are a whole lot of plates. One is here is the Ring of Fire around the Pacific. That's what it is now, and they're moving now. To give you an idea, the rate of movements of most of them is about 6 centimeters a year. Do you know what 6 centimeters a year looks like? Well, it's about the speed of your nail growth. Now, it doesn't sound very much, but geologically, it's massive. And if you've got plates, two coming together, you've got 12 centimeters a year coming together. Now, that is a lot. And if you're thinking about volcanoes, earthquakes, and things like that, that's why you have them. But let's go back. Let's go back to the Precambrian. Remember I talked about the Precambrian? That's what the Earth looked like in the Precambrian. About 600, just at the edge of the upper Precambrian. There was a large continent. There's the South Pole, on the South Pole. Mammoth continent. England and Wales was here, right in the center. And from that time forward, a lot of the rocks you see, let's say up in Holyhead Mountains or Llandwyn Island, all relate to that period of time. So it's a long time, and it occurred at the South Pole. Things started to happen. And this is the progression of what happened. And it's important. I'm not going to spend long on it. But around the order of 450 million years, Scotland, which was part of this continent called Laurentia, moved northwards. Where were we? Down here. That split off that Gondwana and started to move away. And in between, there was a big ocean called Iapetus Ocean. By the Silurian, it was moving closer and closer. And at the end of the Silurian, they collided. And that is the most important thing which I want you to take away. They collided and things happened. You've got uplifts, you've got mountains. Mountains which could well have been, we don't know, could have well have been the height of Mount Everest. We haven't a clue because they've all been eroded off. In the Carboniferous, Scotland and Wales and England are together. There is a suture between the two, not only politically, but also geologically along there. And that is important again, because then we start splitting off another part and we get an ocean between, or a small ocean, and that is where the limestones were actually deposited. Look where we are. At that time, that's the equator. England and Wales was on the equator. So it had moved up in that time, and it's on the equator. And that's the reason you get these corals and all these fossils at that time. Sorry to get a little bit technical, but hopefully it wasn't too much. And it's also the reason why we get all these different environments. We talk about environment, it's in the news all the time about environments. As a geologist, we've always had to think about environments. This one, for instance, this is at Llwydwy Bay. Those are mud cracks. Mud cracks, what does that suggest to you? And the red color suggests you desert conditions, flash floods, drying out. That is what was happening at that time. Another environment is these colonial corals. These colonial corals you can see there. You'll be surprised to hear that you can see those in Rhosneigr. Bit of a cheat, because they actually were brought in as sea defenses. But don't worry, you can look at banks, you can look at any rock, and if you come on my little tour tomorrow, the ones going down onto Broad Beach. There's an amazing rock. You've got granites, you've got piece of ocean floor, but they're part of what's been brought in. Those were probably brought in from the other side of the island, but they are spectacular. You will not see such good quality fossils and colonial fossils anywhere, and probably not even in a quarry. It's just, it happens, it's split. And on the top of that, if you look down on top, you've got a whole series. You've got shells, you've got what's called a solitary coral here, and you've got these little things like here, which are called crinoids. So lots was happening there. But let's think about time. Every time, we should always think about time. Here we have a colonial coral, which is about 10, 20 centimeters thick. Now, what's the life of a coral? I'm not a biologist, but I would reckon maximum about 100 years, maybe a bit more. So that set of sediment there with those corals took about 100 years to actually get produced, which is actually quite quick for that amount of sediment. If you look very carefully there, you can see the internal nature of those coral, the little septa. Go and have a look at it. I'll tell you later where it is, but it is. Back to something a bit more familiar. That is on the foreshore of Rhosneigr, the black shales. These black shales were formed in a sort of deepish ocean. So you get black muds in the ocean. But what is also important, within those, you get these layers of sandstone. And I'm going to show you, a bit cheating a bit, not from Rhosneigr, but actually from Aberystwyth, which is where I live most of the time. But I'm wanting to show a point. That is a very similar rock to what you see on Rhosneigr, but it's better exposed. You've got these black shales with layers in them, and then you've got big sandstone and black shales underneath. For a geologist, you say, how on earth did you get that? Black shales in the middle of an ocean, and then suddenly you get a sandstone. How did you do it? Well, the way you did it is that these come from the shelf or the shore regions, and they goes down the continental slope as a turbidity flow. This sandstone probably was deposited, could have been in 1 hour. That could have been deposited in 1 hour, maybe 2 days, because you've got this turbidity, rather like an avalanche, but an avalanche which is underwater. And an avalanche, you think, deposits itself at the bottom of a hill, maybe an hour, maybe less. So this is an hour. By the way, scale, by the way, that's about 10 centimeters thick. But these muds above, those all deposited by stuff raining out from the sea. These could have taken hundreds, thousands, even million years to deposit very slowly. So you're getting the concept of differential time, 1 hour to maybe 1 million years. And that is what you should be looking at all the time. We now go on to just a brief one. We're going to slightly go through the rock types, which you can see here, but I'm not going to talk about them. And that is really through a cross-section through an average volcanic granite sort of terrain. You have a big magma changer. Magma is molten rock down below, possibly 3-4 kilometers down below, molten rock. And then it sends magma up to form a volcano or these dikes, these splits. We are going to be looking at these here in Broad Beach. We can actually see these happening. And below, we have the older rocks. That is the present day surface there. To get a granite actually exposed on the ground, which was at 3 kilometers at depth, it has taken a long, long time to actually erode off so you can see it. The other major point is that granites are pretty coarse-grained things. There are some, that is about 6 centimeters long. You see these big crystals, or what are called feldspar. It's slightly aligned because they crystallized in the magma chamber very, very slowly over 50 million years. It takes a long time to cool this mammoth magma chamber, and that gives them time for the crystals to grow. But as they grow, there's still movement in this magma chamber, and they will actually align themselves. That, by the way, didn't come from near here. That came from when I was working in central Bolivia, but this gives the point. But here is something which is here, and that is the granite which you saw, and that is a pebble. You can't see them. If you go along all the beaches, you can see all the geology when you pick up a pebble. And this is one pebble I picked up 2 days ago, and that is the granite. Same idea, very coarse grained, but you won't find an outcrop of this. That's the Coadana granite. You won't find an outcrop of it. And here again, the feldspar quartz, a long time to crystallize and get it in like that. The only place which I've seen it is here. This is at the far end of Broad Beach, and this is the contact. Now, when granite goes into a rock, it heats it up something fierce. The temperature of molten rock, roughly about 1200 degrees centigrade, could be larger, could be slightly less, depending on the water content. But when it punches into a rock, it cooks it up, just like the oven. It just cooks it up, and it alters it to a very hard rock. Here we see the Coadana granite, not so coarse grained because it's at the edge, because if it's intruded, it chills quickly and is very, very fine grained. Here you can see that the light pink. Here is the host rock, as we call it, very hard. And this is the geological term would be a hornfels. And there's some quartz veins coming across it. Unfortunately, this is where we're going to go for the field trip tomorrow. Unfortunately, the sand has nearly covered all that. Amazing change of the sand as you go on across Broad Beach, and we'll see that later on. The other thing we said, we have got granites. We've now got volcanic rocks. I'm not going to go into great detail, especially if you go to North Wales, Snowdonia a lot. But here on Anglesey, one of the best places to see them is on Llandwyn Island, and they're these big pillows. They are classic, probably some of the best in the world. And they are pillows, and what they are is magma or molten rock coming underwater, and it pushes it where you must have seen things like on Hawaii and things like pushing into the water. Here we come, it pushes in, it heats, it cools very quickly, and then it pushes another, and then another one and another one, and you get these whole series of pillows. And in between them, when they actually start, water goes through them, you get this jasper. Now, you can pick up jasper. Oh, I've picked up several pieces today, just walking along the beach. You can pick up beautiful pieces of jasper. And I would guarantee that when we go across Broad Beach, I will find you a piece of jasper, which is a semi-precious stone, though the Victorians thought it was. It's very bright red and polishes very, very well. Finally, we have dikes. These are the things which I showed you, the cracks coming from the magma chamber and moving up. And here is one. Gives you a very clear indication. Here's a granite. This actually came from Hong Kong, but it shows you what a dike is. It breaks open, the molten rock goes in and finds any crevices it can. Again, time, how long does it take to form something like that? Probably the initial intrusion as molten rock, and then the first crystallization, very quick. I would imagine probably no more than a few weeks, months, nothing more than that. It doesn't stay molten very long because the rock outside is very cold. And we're very fortunate in Rhosneigr, at the far end of Rhosneigr. This is the far end of Rhosneigr. This is May ground, and the houses you probably see up on May ground. And this is a dike which comes through. That picture of the granite contact, which I showed you, is that. And then there's this dike which comes across. Now, it's about, I suppose, about 10 meters wide, no more than that. And there it is. One of the photographs I showed you right at the start. Here's what we call basalt, a very fine-grained dark rock intruding into the schists and the country rock there. And if you look at the sides of one of those, it's kind of interesting, which you can see tomorrow if you want to have a look. You can see where there is the contact, very irregular contact when you get in detail of the molten rock coming in here. And you can see it's a very, very finer color at the edges. And that is because it's chilled. It's gone in there. You can say, well, that was pretty cold when that came in. And in places, it's injected itself into the country rock. So that you'd have walked over quite easily. But that gives you an idea. The difference in ages of that is, probably several hundreds of millions of years. So it's intruded in. Enough of that. Sorry if this is getting too geological. Shout if it is, and I'll stop. Earth movements. This is what I studied for a long time in various parts of the world. I'm just going to show you how do you determine that there's been lots of earth movement? Well, one of the things is to look at folds like this. This is from the Rhosneigr beach. You can go and actually look at this outcrop. Here's the sandstone, and there's been folded. Very simplistically, it's rather like a concertina. You squeeze it, it folds. Just like a piece of paper, it will fold. And here it is, going like that. The other thing you get along with this folds, here's one of the folds, again from Rhosneigr Beach. Here is one of the, quite a tight fold in the sandstone. And in the core of the fold, and on either side, you get what's called cleavage. And that is where you get a compression, and within the mud, they get this layering like this, which is very fine layering, which of course is the slate of North Wales. That is how you form slate. These are not slates, but they're pretty good. I doubt if they ever made very good roofing slates, I might add. But there you go. You can see them here, and they one on top of the other. So that again is an indication that there's been very large amounts of pressure. Now, one can say, how big were these mountains? And the reason for that, if you go back to what I was telling you about plates moving, this was when Wales Wales and England came in and started to collide with the continent to the north. This, you look at that as a geologist, and you say continental collision. We're talking about big time, similar to what's happening actually gone. India and the Himalayas. India is still pushing northwards at about 6 centimeters a year, and the Himalayas are going up. And even they are rising all the time, but they get eroded. So it's a counterbalance. Remember what the world is trying to do, or what the earth is trying to do. It is trying to get everything down to sea level. That is its aim in life, is to get all mountains, everything down to sea level. So here we've got mountains and we're at sea level. The mountains could have been, 6,000 meters high. I don't know. No one knows. So that is folds and cleavage. The other things is faults. Now, I don't know, has anyone felt an earthquake here in yes? A lot of people, right. Now, where did that come from? I worked for the British Geological Survey for 30 years, and they monitored all these earthquakes. And these are the main faults which cut through. There are lots of others, but obviously you've got the one which goes along the Menai Straits. They're not just one fault plane, they're probably a lot of bifurcating little faults. Now that fault back in the Precambrian, we're talking 600 million years ago, we can see it was doing something. It's still doing something. Most of the earthquakes which you get come from the Menai Straits fault. So it is still moving. After 600 million years, it is still moving. Got the other ones, but this one is the Central Anglesey Fault Shear Zone, they call shear SZ shear zone, which comes through very close to Rhosneigr. If you come tomorrow, I will show you what that looks like, actually what the shear zone looks like. And if I come on to the next one, which you've already seen, this is a shear zone just a little bit further on towards the burial chamber, but on the beach. Here it is here with all these twisted, very, very twisted pink quartz veins, immense amount of shear. That isn't moving now, but it obviously moved in the past. Probably not vertical movement, but lateral movement. And you can ask questions. Well, the question I always ask, how the hell did it do it? And you've got to work out when it did it and how it did. Final part of my talk is probably something jumping right into glaciation, because most of what you see of the landscape here is all due to glaciation. A lot of what I've been talking about here, like mountains, have all disappeared. But what you see now is due to the glaciation. And the glacial deposits of Anglesey are quite varied. First of all, you've all heard obviously about the last great ice age, which was at its zenith about 25,000 years ago, which isn't that long. I think now you can we're now getting to numbers which you possibly can think of, 25,000, maybe you can think about what that is. And that was when it's at the peak. These are global sea level changes, and we're here, and it's roughly, obviously we're at zero, but look at the last ice ages, the last 4 ice ages which had occurred over the last 300,000 years. In every case, the sea levels went beyond what it is now. I'm not going to go into global warming and everything else, but that shows you that even if we weren't around, man, they would still go up 3 or 4 meters higher than they are now. End of that story. But what were the glaciers like? And where did they come from? We have got the mountain glaciers of Snowdonia, and they went down pretty well. The glaciers extended nearly to the South Wales coast. But the main ice sheet came from the north, from Scotland, and went right over the top of Anglesey and went along the side of Wales. I studied one here, some deposits here. They cut off the valleys, and you've got these big lakes, Llyn in particular, which was nearly 100 meters thick of water depth. Mammoth lakes, which were trapped within the mountains of Wales. So that's the general feeling of it. And then we come back to this. I think this picture was taken probably 2 days ago. Looking out towards Holyhead Mountain. Glacial erosion. What's the evidence for glacial erosion? Here, Holyhead Mountain, it has a very, very distinctive shape, and that is due to the ice sheet coming from the north over the south, grinding its way, and as it goes over the top, it plucks material away from it on the downward side of the glacial sheet. So that is called a roche moutonne, which if you want a technical term for it, but we'll see lots of those. It is a classic. So next time you go on the Rhosneigr beach and you look over there, just have a look. You'll now know what it is. The other thing which, of course, a glacier does, it scratches. It's pretty heavy. Remember that at the height of the glaciation, there was a kilometer of ice which went over the top of Holyhead Mountain. That's a lot of ice and very heavy. And lots of the stones in the base of the ice sheet scratched and made a very smooth surface, some little valleys. But if you look carefully, it's difficult to see on a photograph. You'll see a whole lot of striations where those rocks have ground into the underlying rock. The problem is, as not to say non-geologists, but if you look at this, the first thing you'll see are all these cracks here, and those you'll think about. Forget about them. That's immaterial to what I'm talking about. Where I'm thinking of a smooth surface dipping or going at a shallow angle in this direction. A lot of this is later erosion of joints and things like that. And that is one of the things, as a geologist, you've got to look through modern day erosion. We've got under ice. This is Hen Waters. Again, we showed this as an unconformity. This occurred under the ice. And you get a thing called drumlins, which are elongated domes of gravels and things. And those occurred under the ice. And as the ice retreated, they're left as slightly rounded domes. Hopefully you can all recognize this. You've all walked along here many, many times before, which unfortunately, I should go and see it because within the next 5 years, it won't be there. That was a picture I took, 15 years ago? And if you see my book, it's got it in that. There used to be a little bollard of here, or a little hummock here, and these hummocks. This is the glacial surface, again, that shallow dipping surface where the ice came up from the north and over the top. And here are some of the deposits. As the ice retreated, you get these deposits laid down on that surface. That was taken 2 days ago. That bollard is gone. This is nearly gone. And what with rabbits, bit of sea, mainly children actually, climbing it. It is slowly going. And I would say that within 5 years, that will just be a plainer surface. There'll be nothing on top. So things are changing. This is, as I say, it would have gone anyway, but children and rabbits are doing their best. And in some of these deposits, which you get these, you've seen them all over. This one in particular, I took that picture this morning, actually. I thought, gosh, I better put one in. I think probably kids have jumped off this for years. It's a big block of rock on top of these shales. This is an erratic, which is a big boulder caught up in the glacier, and as it retreated, it dropped it. It just dropped it down. Here are some more as you go over towards the burial chamber, right in the middle. A very classic. Here we go. We've got the retreating ice sheet. 25,000 years, it started to retreat. By 12,000 years, the ice had gone. Okay, now 12,000, you may be able to understand 12,000. But here they are, they dropped them, and you can see them. There are several of them. If you go over you'll pick them up. They're just isolated, they're erratic, and quite often there'll be a train of them as you go north, where they dropped and dropped and dropped. Some of these, this one in particular, its source, where did it come from? Certainly from the north of Anglesey, but some of them come from the way right from Scotland. So they've been taken by the ice and dumped. Now, this surprised me. This photograph you will not see again, or you won't see it very often. This is Broadbeach, taken about, I suppose, about 8 years ago, as I happened to go along. What I'm looking at is this deposit here. It's very, very rarely exposed, and it is peat. It is peat here and some clay underneath, and it goes along all the way along here, and it also goes pretty well all the way around Wales. And it lies between high tide and low tide. It's in the middle. So what does a peat suggest to you? A peat suggests to you that it was a forest, it was some form of land, and it had trees growing and dropped it and made the peat. So this was the level, and this one has been dated at 5,000 years. So we're getting closer. So this is about just over 5,000 years old. And there were trees coming out of this. To prove it, actually, I think I've seen a picture in Triada Bay. You actually see trees. But nearer to where I live, near Aberystwyth, in a place called Borth, you have these tree stumps. It's the same age, it's the same position, 5,000 years. And here are these beautiful trees all the way along. That is a classic. It's a beautiful, as I say, what it does mean that the sea level has risen. It has gone from there, which is about between high and low tide, and has come up to present time. So sea level from the last 5,000 years has risen in that time. About 2 minutes. No more. 2 minutes, you're okay. And there it is in more detail on Broadbeach, with the clay is underneath peat. Very, very close now. Interestingly, again, I took this 2 days ago. Can you see where the water is coming out on Broadbeach? There's no sign of that peat because it's all covered by sand. But that's where the water is coming out, is on top of that clay layer. And you'll see it all over the place. So that peat layer is running all the way along there. Promise, David, I'll be there. Finally, promise, don't get too worried. Well, yes, I know you want the philosophy in a minute. That is a clay layer. That is a peat layer in the boat pool. That's only been exposed, I don't know, I've only noticed it within the last year or so. But if you go down to the boat pool, you will find that peat layer. Lots of people get their boats stuck on it in their trailers because it's very squidgy and everything else. But there, if you look, you'll find twigs. Again, it's the same level, about 5,000 years ago. So I've gone back too far. How do we go back? That way? No, that way. I've lost the whole lot now. Come on, I need somebody.
I'll help you. No problem.
So this is the end, really, of my talk. Is it philosophy? Well, it's a natural philosophy. Geology was called natural philosophy in the old days because you had to have a philosophical bent to think about things. Just put that in because everyone's got these beautiful sunsets. Now, I'm going to ask you all a question because we're talking about time. How long do you think it takes for the sun to set? If you look at the sun and you see it going down below the horizon, it touches the horizon. How long does it take before that goes below the horizon? Has anyone got I actually asked my family, my immediate thing, and we had anything from 45 minutes down to 2 minutes. 7, 4.5. What? 8, 9, 3. Well, I'm not going to answer it. Just go and check it. But you'll be surprised. I always get it wrong. It's shorter than you think. It goes down very quickly. And for ancient people, that is a thought of time. You can see time going there. So, of course it is. It's different at the time of year. But overall, I'm talking about Rhosneigr, there will be a change, but overall it'll be roughly the same. I think, and I'm guessing here, I may be wrong, but please check me and say I'm wrong. I think it's around 4. It certainly isn't 3/4 of an hour. But 4.5, someone said, you're probably dead right. That's right, it is. But what is interesting to me, let's say, you know, in ancient times, literally prehistoric, that apart from the moon and everything else going, it's quite an interesting, that shows you time going past. So that really concludes my talk. Sorry, it's been not quite as philosophical as somebody may like, but if you have a problem with what I've said, get this book, which was written for children. It was written for my grandchildren, because I've been coming here for nigh on 40 years and I've walked over these, and I wanted the children to start thinking and looking and making. And it's there, and it has a mythical side, but it also has a geological story. So there are 2 parallel stories, and that's important, because the geological story could be wrong, but it's just as exciting. Thank you very much.
I think now's the time to ask any questions of Chris, or actually sort of raise anything. Yeah, well, just 1 second, sir. So I'll try and see that everybody has a fair crack of the whip and can actually sort of say something. We're going to be a bit pushed this evening if we're going to close by 8 o'clock before food. But who would like to start me off? Yes, sir.
Could I ask you about the sand in Rhosneigr Bay? Because it moves around an awful lot.
It most certainly does.
Near the airport, there's lots of big sand dunes. It seems to be the predominant waves, there's a predominant weather systems coming from the southwest. It's gradually moving all the sand up there. So is that going to continue, do you think? Are we going to end up with no sand at that end of the beach and a lot at the other? Or?
But what often happens if you go over 30 or 40 years, suddenly it will all get stripped off. They'll get stripped off, like you could see the peat, that's all gone. Now it's under probably about at least 1 meter of sand. You don't even see it. Even in Rhosneigr, it's changed radically over this winter. It's gone from, you know, you can see exposed rock, and then suddenly it comes in. This can be a lot to do with storms, sudden storms, different variations of which way it goes. In South Wales, in Llantwit Major, if anyone knows, they started dredging sand offshore. And what suddenly find that all their sand on their beaches disappeared. So there are lots of reasons why it can happen. And the sand dunes are particular. I think there's a talk on sand dunes. They find it, and which is really fascinating to see. Because
Tomorrow evening.
Yeah, I'm going to go to it. I think it's fascinating because many of these sand dunes, their main formation was in the Middle Ages. For what reason? I think there was a cold spell or whatever. But it's an interesting question. It needs quite a lot of study, and it's all to do with tides, winds, storms, and everything else.
Okay. But thank you very much, Chris. So everything is allowed here. So sorry, there's a gentleman here. Can we just use the?
Yes. So what I just wanted to say is, because we're trying to stream this and capture it for other people, we like to use the microphones to ask questions. So if you can just wait until I get to you, then that'd be brilliant, Chris.
Thanks for a great talk. Is it on?
No.
Thanks for a great talk. Can you hear me?
Yep.
I just want to get a plug in for Geomon. I don't know whether you all know, but the Isle of Anglesey is an international geology site, a World Heritage Site for geology, and the organisation looking after it is Geomon, and we have a centre in Amblot, and it's worth a visit. It's on the dark side of the island, as we say, in Amblot, so you won't visit it normally, and you should see it because we've got a great display there. We've got your book on sale recently, thank you very much, and it's worth a visit.
All right, thank you very much.
Could I say that in the book, the newest version, we have got the Geomon logo on it, just because, which is what I wanted to do. It's a great honor that they've got a UNESCO site here on Anglesey, and it's very, very important.
Okay, Charlie, can we take the mic to Mr. Parsons? Yes. Sorry about this.
Charlie.
Better than Mr. Parsons. From a geological point of view, do you think current warming of the planet is a natural phenomenon or a man-made one?
There have been, I couldn't say, there have been United Nations debates on this, and last night on television, I was going to bed, there was a very, very good synopsis going way back. I would say that we are on a global warming cycle, whether we were as man on it or not. You've got to remember that very, very in between what we call the interglacials, there were hippopotamuses running around Trafalgar Square. So it was very temperate when it went during those times. But what it does mean, it's an incredibly debated question. I think even I wasn't skeptical, but I wanted a little bit more proof of it. It is coming that we have changed, but my personal feeling is that we have made a mess of the earth from lots of other reasons, not just the amount of CO2. You've only got to see plastic, and you name it. There are a lot of things which we've done, and we've got to sharpen up. Whether reducing the carbon dioxide in the atmosphere will help immediately, but if we don't, just to give you an instance, which I always find very, very thought-provoking. If you think of how long man has been on this earth, and you compare it with the dinosaurs, which were they got extinct. I know it's a meteor, but for every day that man has been on the earth, dinosaurs were on for 8 years. We've got a long way to be as successful as a dinosaur. So, and we haven't been on very long. And it doesn't look good, would be my feeling. And it's a very good question, but it's one which could take a whole gamut of times.
Roger, I think you put your hand up.
Can I ask you, Chris, about the Mona complex?
Yeah.
Which I know nothing about, but I've been told that it exists.
Yep.
And I've been told that the Mona bit of it is to do with this island. Is that?
Yeah, it was named.
And does
I seem to have skipped over one of the first slides. I don't know where it went.
Have I missed something? Am I
No.
exposing myself to missing?
No.
Right. And I was told that it goes across the Atlantic or under the Atlantic Ocean. Is that?
Yeah, well, anything. Remember the two, Europe and North America were together. And it's only in the last 50 million years that the Atlantic has opened. So the rocks we see here are very similar to what you see on the east coast of the States and Canada. I forgot to. I must have. I don't know where it went. Has anyone heard of Edward Greenlee? You will certainly, but Edward Greenlee was an amazing man. And the geological map, I thought it was on the slide there. The geological map, which you can buy for 18 quid from the Geological Survey, is an amazing piece of work. He spent 25 years mapping the island at his own expense, the island of Anglesey. And the Geological Survey agreed to publish it. And it's got 2 volumes. It stands pretty well intact. Yes, there have been a few geological changes and theories along the way, but it is an amazing map. He was an incredible man, and it was published in 1920, but he spent 25 years doing it. He's lived on the island and did it. It's worth looking at. And he named a lot of these formations, including the Mona complex, which is the Precambrian. It's the Precambrian schists and gneisses, and included the granite as well. So it's the oldest rocks on Anglesey.
Okay, thank you. I think Mark, you've got your hand up.
Yeah. Oh, I did. Yeah, because I'm holding the microphone now. Sorry. So, unfortunately, today we heard about the death of a fantastic scientist called James Lovelock, who was a proponent of the Gaia hypothesis. And one of the things that we've learnt over the time since he proposed that hypothesis was that our rocks are actually in some sort of dance with the biosphere. And Chris, I was just wondering whether you had any thoughts about that and his contribution to science?
I'm sorry, I don't know too much, but if you're talking about the biosphere, we were showing this wonderful set of corals and everything else, and they all become rocks. So all the rocks outside in Rhosneigr, they do have fossils in them. Very rare, and they're called graptolites. And we're talking about the very old rocks. These were planktonic things, and that's how they dated them. The reason why they could make that big column there with the Cambrian, Ordovician, Silurian, and things like this is that they didn't know the exact age, but they looked at the evolution of such things as graptolites and shells, and they can then change where the things, basically sea level or something changed. So the context of rock and the biosphere is right there. You've only got to see the peat. That is exactly, that's a evidence that it's right there.
Fantastic.
Thank you. Someone from the back, perhaps, because you can hear, hopefully, from the back of the room.
If you're worried about that, you think, you're going to make a faux pas or you don't really understand, what I might suggest, I was out with children on, when was it? 2 or 3 days ago, and it was a lousy day, and we went onto the beach, and I've taken the children from Rhosneigr School, the primary school, had about 20 of them on there, and the questions they ask are really fundamental, and it keeps you on your toes. So but that is on an outcrop. I felt a bit out of my, not quite out of my depth, because I've done many lectures on particular scientific issues, but in this case, the best place to talk geology is with a rock underneath you, standing. And then you see and you say, well, what happened? And you then start to think, your mind goes, well, why is it like that? That's why I brought this rock along. You're not often going to see an unconformity. That's how it should be, like that. And you can actually see the amount of geology in that is phenomenal. And that is true. So if you come along at 2 o'clock tomorrow, going across Broad Beach, walking across Broad Beach to the other end, I'd be delighted, and you can open up, hopefully.
Okay, so we want lots of questions at 2 o'clock tomorrow, Broad Beach. Weather's looking okay, I think.
Yeah.
So,
We're going, the ramp going down from the village, going down to the village. There's some black rock. All these black rocks there. Ordovician, they're right at the bottom of there. And I'll start there, and I will walk right across the other end of Broad Beach and a little bit beyond. And if people are still interested, I will carry on to the burial chamber, but where you can see lots of other things. But that gives you a lot. And it would take about, an hour and a half max.
that's great.
Children are welcome. I like children.
All right, thank you very much, Chris. I think we have the gentleman at the back, please.
Yeah, just a quick question. We talked a lot around the physical erosions that's caused a lot of the landscapes in the area as well. You touched on CO2 levels going up as well, which has an impact on ocean acidification. How much is that going to impact in the area more? Enhance ocean acidification plus physical stuff. Do we expect a big change going on?
Well, let's just go back to when, the height of the Ice Age, which I told you was 25,000 years ago. Sea level was about 120 meters lower than it is today. 120 meters. It was phenomenal right across the world. And since that time, it has been slowly rising as the ice caps and Greenland and all the various other things starting to melt. We saw the peat. 5,000 years ago, the average sea level here in Anglesey was probably 3 or 4 meters lower. And it's rising. It will continue to rise. But I wouldn't have worried about it a bit ago, because you'd say, well, it's on a geological time scale. But the problem is, as you global warming, you get more storms, you get more things thrown in, there's a lot more erosion, the whole thing, in addition to the fact it is rising. So the answer to your question is that how you do it, I mean, this is a global question with politicians and everyone else. People do not know what to do, and it's not, I can't answer this now. We could argue for the next, I don't know.
Brett, I think you've got your hand up next. Sorry, Mark, you have to sort of run from one end to the other with the mic. But, sorry, Lord, we'll come on to you in a second.
Hello?
Yeah.
Right. Paris Mountain.
I thought you may bring that up.
Yeah, because you didn't mention it.
I tell you the reason. I was going to, there was a lot of other things we were going to mention, but you've got to, I don't know how long I went on, rabbited on for, about 40 minutes. If I brought in that, I worked on Paris Mountain. I've been down when they put in the shaft and everything. I was going to bring a piece of it, absolutely spectacular. I didn't bring it, which was polished piece from about 90 meters below ground. Interestingly, Paris Mountain is at the end of the Ordovician Silurian, when there was some volcanic activity, which are these, I was going to discuss all these ash flow tuffs which come down at about 120 kilometers an hour, but Paris Mountain is thought to be related to what they call a black smoker. And a black smoker you see nowadays in, let's say, the center of the mid-Atlantic ridge, and it's where volcanic waters, heated up waters, come and they plumes and they're black, they've got a lot of sulfur in, and slowly they make a column. And that's what they think happened there, that this was originally a black smoker. And that's where all the elements came from. But they are trying to, that was Kaminko started it, and then Anglesey Mining, and I think they're starting to try and do it again. I make no comment whether you should buy the shares.
Sorry, this is investing in Paris Mountain.
Yes, absolutely.
Great. Yes. Yes.
Hi. We're talking about the sands and how they move. At the moment, there's a great lot of fuss about the movement around Fairborn and how Fairborn is going to be wiped out by climate change, which of course is a load of nonsense, because Fairborn is actually quite a modern piece of land. It occurred because of longshore drift, which has been coming up from the southwest and is gradually eroding now, and is all ending up around Harlech. And so there is a big lump of rock in the middle of Fairborn, which they built the church on, and a few other shops. But the rest of it is all mud and the sand on shale and mud. And that is just going to move. And if you go back to the Bible, the talking about the man building his house on sand, pretty stupid thing to do.
Very similar to Borth, very similar to what's happened at Borth. They spent millions on putting sea defenses there. It'll go around them in the end. I mean, in essence, you've got to live with it. You've got to learn to live with climate change and sea level change. That's what you've got to do.
Well, this is what our ancestors did. Yeah. I mean, it's only because we decided to settle down and farm that weather has become a problem to us. Before, things flooded, you just moved. I mean, if you look on the Somerset levels, they used to farm on the Somerset levels in the summer, and they would move into the Cheddar Gorge, over the winter area, because the Somerset levels always flooded. And it's coming back. Yeah, but it's very fertile.
All right, thank you very much, John. So we didn't have anybody here from Fairborn who could offer the person who can't know. Oh, there is somebody from Fairborn.
There are forests there as well.
I can't see a hand
there's
up.
bound to be. There's submersion. There's bound to be. I don't know of it.
Okay, Lorna, I think you wanted to say a few words. I think we're going to move from sort of large rocks now, Chris, to sort of finely granulated sand.
Yeah. Thank you, Chris. That was excellent. Just to give a quick plug, and you did mention it about a presentation tomorrow in Rhosneigr Village Hall. A lady called Hannah Lee, who works for Plant Life, and they've been doing this dynamic dunes project. So you've probably all seen where some of the trees on the beach around the oyster catcher and some of the dune work that's been done. So if you want to know more about what they're doing, come along to the Village Hall tomorrow at 6:30. And also she's very interested in getting people involved in citizen science projects, so actually doing some of the monitoring of the work they're doing, so going out there, taking photos and feeding back. And so it's very much more modern geology than we've heard about tonight, but just wanted to have a quick plug for that. So thank you, David.
Thank you very much.
And it's free.
I think you're all going to have a busy afternoon tomorrow, because you've got to be there at 2:00. Then might be a break for a pan out, and then 6:30 in the village. Is it, what's the entry fee?
It's free.
It's free. Rather like here, you know, so free is good. Okay.
Yeah, absolutely.
You said that. Yes, anybody? Yes,
Chris, hang on a second.
Have somebody who's not had a chance
But-
to speak.
So, anybody
Otherwise,
else?
Otherwise, we'll come back to you, Chris. Yeah. This is your big chance.
There we go. Come on.
All right, sorry. Lady
Yes.
over here. Yeah.
You showed us several pictures of rock formations and pointed at different levels and said, and there's a gap. How do you determine what happened in those gaps? What are the clues that you can look
That's
for?
an
I'm
excellent.
glad you've asked that because I've been worrying about missing.
It is an excellent question because, in fact, what that gap is, let's say the Jurassic is missing here. It was deposited all across Europe, you know, the chalk and everything else. What it means is that at that time, Anglesey was above sea level. So it wasn't, so the basins which were depositing these was elsewhere. And that is how you figure it in between. But it is a gap and it's a missing gap. Good question.
How do we know it's missing, Chris? Just because, you know, we
Haven't you been listening?
He's a lawyer. He'll
I think
always
I'm
come back
getting
with
the
that.
cross-examination from the defence.
So, Chris had another question, and then I have as well. Unless, Mike, beg pardon, Mike.
we've been calling you Crystal.
No, you've only mentioned it twice. I may change my name to Chris.
Okay.
Sorry, I just wondered whether I could mention Kemlyn,
Mhm.
because Kemlyn Bay is absolutely brilliant. Every rock in Anglesey is there as a pebble, so you don't have to traipse over the whole of Anglesey. You can see them all there. That rock, that pebble you had at Cordana granite, is exactly the same as one I've got, which my grandchildren collected 25 years ago from Kemlyn. So even the erratics are there. You know, there's pieces of granite from Scotland there. There's pieces of stuff from rock from Ireland there. It's just an amazing place. And as the tide goes out, they're all washed clean for
Okay.
it to have.
I was also attracted by the prospect of jasper on the beach. It seemed it has a sort
Well, you'll
of
find jasper
a
there.
monetary value. So we
You'll
can sort
find
of
a
get-
pebble of jasper.
Right.
Yes, I've got several. I picked them up today.
Yeah.
Several jasper pebbles.
Kemlyn is brilliant.
Mhm.
There's a few billion there. So they won't miss a few pebbles.
Okay.
Mike, I really apologise. I've got a terrible face for names. Just really, it's happening. Yeah, no, it's not your fault.
Anyone?
I've got another question because and it's a question because I've got the microphone, and it's because I know Chris had a little interaction on this. Now, one of the things that in our world today we have to manage is where we put nuclear power stations, and I understand you had a little story about the placing of Wilver, and I just wondered whether you could just give us a little flavour of what a geologist does that makes a real impact in real life.
Very much so. And to a certain extent, I was called up to give they had their dikes, which we were talking about. And one of the things, if you put a nuclear power station, you've got to prove that there's been no proven movement beneath that power station. It depends whether you're in the States or here. Let's put it's 50,000 years. It's probably more than that. You've got to prove it. And that's quite difficult to actually prove that there hasn't been movement or a fault movement. And one of the ways they did was to look at these dikes which went under the Wilver Power Station. And they asked me, and I said, well, actually, I know a wonderful dike, and I'll show you the map there, the other end of Broadbeach, where you can see a lot of the, that they have moved. Now, the question is, what age is that dike? And if you look at Margaret Wood's book, which is absolutely superb, I only recently, it's really superb. She was saying that, and even Greenley did, that there are two ages of dike, one post-Carboniferous and one tertiary. If they're tertiary, we're a bit in problems. The question is how they determined it. Now, I haven't studied that in great detail, but you are using geology away from the site and saying, look, this is what's happening here. It's got to have happened over there as well. And that's what I've done all through my life, from landslides to deep foundations to tunnels. You use geology all the time. I even spent, I don't know if anyone knows St. Dogmiles. Does anyone know St. Dogmiles? There was a landslide in St. Dogmiles many years ago, and I was rung up at about 8 o'clock in the morning. And this is, if you're a geologist, I was working for the Geological Survey. They said, can you come down to St. Dogmiles? There's been a landslide. And I said, well, fair enough. It was pouring with rain. And I met the chief engineer on site in St. Dogmiles. And we walked over it, and there'd obviously 2 houses had to be evacuated because there were big cracks in it. And one farmer was getting really perturbed because there were 3-meter high scarps in their field, and they had to get all their prize cattle out to market immediately. And so there I was. We spent an hour and a half on this, and I walked over, and you can't see very much, except it's in rain and in mud. And the guy said, would you mind come down and just talk to us at the county offices about what you've seen? I was sort of worried here. I've only been there an hour and a half. Went down there, and I walked into their offices and to their auditorium, and there were about 100 people in this big auditorium. All around, there was everything from the WI with their canteens and their premises to the fire service, to the police. And the chief executive was there describing what they were going to do. It was a sort of really tense moment. And he turned to me and said, Dr. Fletcher has arrived, over to you. And the question, what they were asking, should they evacuate St. Dogmiles right away? They were ready to do. They got the blankets, they got everything ready to go, and they were all scratching at the ground. You could see it, wanting to go ahead. So I had to make a decision. Should you evacuate? Was there a danger that the hillside was going to take out? And they had on a flip chart in front of them St. Dogmiles, and they had this landslide going across the Tywey, flooding the Tywey, backing up to Cardigan and flooding that. I mean, it was a mammoth operation, what they said. And I said, for the first thing you should do is to take that. Don't show the press that. I said, this is, and I had to make a decision on the spot from what I'd seen. And I said, don't evacuate. Because once you evacuate a lot of people, you've got a big problem of getting them back. And I felt, from what I'd even seen, landslides generally move and they stop. They actually stop. They cease. They get to their equilibrium position, and they're not likely to move again until something else happens. So I said, no, don't just. But I did say, you've got to cover your back, haven't you? You've certainly got to cover your back. And I said, right. Well, what I would do was to go out and put a series of pegs right across the landslide, and I would monitor them on an hourly basis with lasers and everything else. And if there was any movement whatsoever, which over the next 24 hours, because I'd already called experts from the headquarters in Nottingham, the Geological Survey, to come. If there's any movement, then we think about evacuation. And that's what they did. And in the end, they never had to evacuate. But it was an ongoing, it was a fascinating.
What initiated that?
Do you want me to do that in a short way? It was basically the fact that no, it was heavy rain. But the big problem was they built even the cathedral or that and everything else and houses right across an ancient landslide, which goes back to when the original ice moved back, and it had all started to move. And the reason it started to move, the water board had stopped they had a spring at the top, and that's where the water went for the village. And they stopped it, and they poured all the water at the top. They allowed the farmer to make a dump right at the top. He had a little scarp behind his farm, and that's a great way to bring in tippers and tip back, and they landed on top. So they weighted the top. They put water in. Those are 2 things you should never do. So that's what started it. And the council allowed it all to happen.
So you made a good judgment call at the time, Chris.
Thank you.
You made the right judgment call.
Yeah, because if you evacuate, it's all very. But it was really a spur of the moment of just saying, what should we do? It would have been easy to say evacuate, but in fact, it would have been a nightmare.
It was a
massive bit of putting money onto you.
It was. I've never been in a situation. I looked at this whole cascade of people, just like now, actually.
I think we've probably got time for another question, or we can continue this over supper. Clive. Sorry, the mic needs to travel round. Yeah.
Might not be philosophical enough.
Everything's allowed, Clive. You can say whatever you want.
It's more to get some stories or some idea of the background. You've mentioned both central Bolivia and also Hong Kong, and I think you mentioned to me once that you were involved with the airport construction in Hong Kong. Pick either one of those two, but I think it'd be fascinating to know why or what you were doing there.
I was working, there were two things. I was central Bolivia. I was working for the British government as technical aid to Bolivia because it was one of the poorest nations. And they decided to map the whole of the eastern part of Bolivia, which is jungle, because there were no geological maps. And for development, mineral resources and a whole lot, we sent out from the British Geological Survey, we sent out 10 geologists. We set up labs and everything else. And then we started to cut our way through the jungle. And it wasn't sort of high tech. We're talking about a long time ago, in the 70s. We didn't have any aerial photography. We had the first satellite imagery, which was absolutely fundamental. But we found immense different types of rock, and they have found deposits and things like that. So that was actually to help the economic growth of Bolivia. But then I came home, and they just opened an office in Aberystwyth, the Welsh office of the Geological Survey. And I looked at it, I looked at Aberystwyth. It had mountains on one side, sea on the other, had a university. I said, we'll go. And also education was good in Wales. So I came and I've never left.
Thank you. I'm always very impressed by Chris and surviving in the Bolivian jungle. He seems to be, uncomplaining. Sorry, Glenys. We'll take the last question from Glenys.
Thank you. I found that most interesting. But as a geologist, you rely very much on the level of different layers of rock as you find it. And so far, it seems to be reasonably pristine. What will future people, when we're wiped out, what will future generations make of spoil heaps where the ground from many meters underneath is now on top? And places like central Australia, where people have tunneled and they've got spoil heaps and things on the surface. And the whole layering system has been made chaotic. What will happen then?
A very good question. I've often thought about it, let's say 200 years, what this earth will look like and what will future generations make of it. But I think your point was, in all cases, what you're looking at is what we call made ground. In other words, somebody has made it. They've brought it up and dumped it. And you can recognize that. And you'll be able to recognize made ground quite relatively simply. You will, rather like archaeology, you'll be able to recognize it. So let's say if we go, several centuries in the future, your guess is as good as mine. But at times I'm pessimistic, but you've got to be very optimistic for your children and grandchildren. And I think that is the crucial thing. You've got to be optimistic, and we've got to think, at least nowadays, no matter what, we are thinking about it. It is actually in the debate.
The KT incident.
Yeah, we did. Yeah, we did.
Thank you very much, Chris. Can I just confirm on practice about it? Nathan, we're all ready for take orders for food?
Food will be ready for, they're still having the supper club in there now.
So we've missed out on the gourmet dinners.
Yes.
Sorry about that, folks. Yeah,
So
okay.
it will be from, I think she said it will be about 8:30 and all food will be done then. So if you do want any more questions,
No, I want my food.
Sorry, food will be ready from 8:30.
Yeah, you'll still do orders after 8:30.
Any way of bringing it forward, or?
You've got loads of stuff in there. I'll supply,
Right, I'm very sorry about that, but look, can I just a few housekeeping things. We meet tomorrow at 2:00 for enthusiasts. So when Chris will do one of his legendary tours, and then at 6:30. Sorry, ladies, can I just sort of can I just finish speaking? Sorry, can I just finish speaking and then you can speak? And at 6:30 there is the Dunes talk in the village hall, and then next up we next meet. I think we're going to have August off, and on the 8th of September, I did see Derek in the room. Is he? He's gone. Sorry. Yes. Well, we've got Derek Brown speaking on "Am I a Ghost in a Machine?" The problem of consciousness, and that's all to do with how do we know that Chris, for instance, isn't a cyborg or a zombie? I mean, I think we're sort of conscious of it. I'm sure he's not,
I am.
but we're conscious of we have our own consciousness, and so and the other thing is the board of the Think Rhosneigr CIC. We did decide it might be fun if people had the option of coming dressed as either a cyborg, zombie, or non-humanoid. So I think I did have a few enthusiasts. I think Roger and myself were up. Can I just take a straw poll and see who would be interested in coming as a cyborg or as well? There would be a bottle of wine for the best turned out zombie.
I'll do that.
We've got 3 of us now, so think about it. I think we become more enthusiastic as we go on. And then, sorry, the microphone. Right,
Okay.
sorry, but can you hear me? Yeah.
Is
I
it
can't
turned
raise
off?
my voice. And then also on the 6th of October, AC Grayling is coming to speak to us. AC Grayling is coming to speak to us. I think we'll be having that in the village hall. We think there will be a high demand for his talk. I've heard him speak twice, and the content and delivery of his talks is first class. So, Mark, I think you've got the printed tickets for that. We are going to have to charge for entry because of certain expenses that we have to cover. The cost is £10, and then we're arranging for food and drink afterwards. So, Mark, I think you've got the tickets.
Yes, I've got the tickets. So what we'd like is I've spammed the whole Think Rhosneigr community that we have emails from. If you haven't received an email from me saying, would you like a ticket, then please get in touch with me and I'll tell you my email address in 2 minutes. But what we'd like to do is if you could buy your tickets by paying via backs, so we don't need to use cash, that would be fantastic.
But
So-
cash is always acceptable, isn't it?
No.
Oh.
So in the first instance, no. Can I just have a quick show of hands who received emails for this meeting? And if you put your hands down and just put up your hands if you didn't receive an email for this meeting, right? Those
Denise
people.
and Bruce didn't, but they're going on the list.
Hang on, yeah.
Sorry.
So the people that just put their hands up, if you just come round and see me, I'll take your email addresses and make sure that I can spam you as well, and there will be no hiding place ever again. Of course.
Obviously, these talks have been going on for a while, and I've obviously missed them. How do you actually generate, tell people
So
when they're on? Have you got a?
That's a very, how do we tell people? Yeah.
So
Obviously, I didn't know about the one on the, the sand one, which is quite interesting to me. So how do I, I just live up the road there. So
Yeah,
effectively,
yeah.
how do I find out about
So
it?
I'm afraid it's word of mouth, Facebook, and
So is there a Facebook page?
there is
Yeah, and there's
And-
Rhosneigr activities.
yeah.
Okay.
And the other thing that we tried to do is put notices up in the local establishments, sort of on their pin boards and stuff like that. Yeah, 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 yeah. Thank
Okay.
you. Yeah.
But are you on the mailing list? You're not, obviously not on the.
But come
Do
along
you
and
want to get, yeah, that's okay.
yeah.
Sorry, Susie, you had a
Yeah,
comment.
if I can have your email, then I'll spam you to death.
Yeah, I've just no idea. Who is he?
Well, he's not. Okay, sorry, yes, good point. Everybody knows who AC Gray.
No, they don't.
Oh, right. Sorry. No, no, don't worry. No, not. Yeah, thank you very much. No, not to be confused with Christopher Grayling. There's the person who messed up all the railways and things. And no relation, I think. But that's a good point. AC Grayling is probably the country's leading philosopher. And so I think it's important, you know, you've got to consider that you might, this is something you may want to take your grandchildren along to sort of say, well, look, or kids, and, you know, because they will have heard the great AC Grayling speak, because in my humble opinion, he'll probably go down as one of the great British philosophers of the 21st century. The really interesting thing is that when I spoke to him after the Hay Festival, I don't have a name personally, but Susan and I were talking to him. He spent his childhood holidays actually at Le Bon Sauveur convent, which is now the Akeldra Centre, and then was marched off swimming at Porth Davach. So it sort of rather awoke in him a sort of some childhood reminiscences. And to my amazement, I said, well, do you ever speak outside London? I mean, he's a much in demand. And he said, well, yes. And would you be willing to come to Rhosneigr? So we knew about Rhosneigr, knew about Triada Bay and Holyhead. And so he's rocking up on the 6th of October.
It's also the leading chair of the humanists.
He
of
is.
Who, sorry?
The humanists.
He is.
Yes. I mean, he is a humanist. He's not a theist or a Christian. Sorry. Yeah.
And we listened to him at the Hay Festival, and he is really, really fantastic. Really
Give up. So I want Brenda and Yen, I want you there as well for AC Grayling. I think you'll, yeah.
So yeah, the subject is climate change and social justice.
Social justice and also artificial general intelligence, and is that getting out of control? So he also speaks largely, his main emphasis is on the democratic deficit, and you will also be able to get his, if you do a search, you can get his latest book on the topic. But I think his talk is formidable in terms of both content and delivery. You know, he spoke fluently for an hour and dealt with questions, a bit like Chris here, you know, and it was really good. So please don't miss out. I mean, I think we're going to make tickets available for everybody here first before we start trying to sell elsewhere. But we are limited to space in the village hall, I'm afraid. Mark.
No, you have missed.
So it really only remains me to, just before I thank our speaker, can I thank Bobby and Mark, who incredibly sort of patient with all the technical stuff and streaming. You know, I think they've made the wise decision to involve me in that. And also, Chris, I take back everything I said. I mean, it was a real tour de force, and I think you were sort of a sense of, with the questions, you dealt with those brilliantly. And all I can say is Rhosneigr Rocks will never be the same again. But thank you very much indeed. And can we show that in the usual way, please?
So don't forget that Chris is here now with his pen, and if you'd like to buy one of his fantastic books, they're here. But that's me saying that, and yes. You can.
Thank you for that. Thank you for doing everything. Made it nice and smooth. Well,